Okay, so welcome to this opening day, the presentation of this new master degree in data science. This very short event will be organized as follows. So I will give first a short introduction. So I will give you some general information about the program and questions concerning this first part, so how the course is organized, questions about admission. I will postpone these questions later, so at the end of the talks of our guests will be here, and some of us will stay here, and we will be happy to answer precise technical questions, because I would like to then give space to our guests. So we will have 3 talks when our guests will give their own vision of data science and the application of data science. And so I will try to keep the part of my presentation as short as possible. I'm going to start by saying that this program has involved 6 entities, so 5 departments of this university and an external partner. So the departments are the Department of Mathematics, of course, the Department of Information Engineering, the Department of Biomedical Science, the Department of Statistical Science, the Department of General Psychology, and then the external part is FDK, the Fondazione Bruno Kessler, and one of our guests is a member of the OFDK, and we'll say 2 words illustrating what FDK is. FDK is a foundation which actually manages a impressive number of research centers in the province of Trento. So I was saying this is really a joint effort. I mean, the whole program has been really designed and built with the collaboration of members of all these institutions, and so it's the way the program is designed is really the multidisciplinarity of this program really reflects the way the program itself has been designed. So, first, why a master degree in data science? This could even be, maybe there is no reason to really give an answer to this sort of trivial question, but the point is that, to be a data scientist in the sense that we understand it, is really to put together skills that come from different areas. So you have to explore data. Certainly there is a lot to do with statistics, but then you have to organize to make computations of data. So the contribution of computer science is also very important. Then you have to make models and test models. So again, is important the role of mathematics and of statistics to make and test models. But then, of course, when you do data science, when you analyze data, you have to have in mind what are the objectives of your work, and so what can be done, what useful can be done by analyzing data. And then you have to talk also to the non-specialists when you have to present your results and to suggest the strategies that are suggested by the data analysis. Also, the so-called soft skills are important. So this is certainly something that also should be part of a program in data science. So all this shows that the approach is really multidisciplinary and involves merging skills coming from several disciplines. And so it is not really, we have thought that it was not wise to try to designed to put this program inside one of the existing master degree, but that it was really worth to build a new master degree to really reflect all these skills, as I said, coming from many different areas. So why in Padua a master degree in data science? So I would say that the main reason is the fact that data science has, in terms of research and activities, when I say research, I mean both purely academic research, but also applied research, collaboration with the private institutions, for example, but also with public institutions, non-university public institutions, has been reached since many years here in Padua. So the research in data science involves all the departments that have been mentioned so far. So we have research in computer science and engineering, for example, concerning, for example, data and process mining, network security, but this is just a spot, so there are many topics that I will not mention just for brevity. Then there is statistics, so analysis, for example, of economic data, biostatistics, bioinformatics, environmental statistics, and so on. Mathematics has to do with data science. The research in mathematics in this department has to do with data science, with stochastic models, large-scale optimization, numerical methods, so on and so forth. And also topological data analysis, just to mention something which is more on the side of pure mathematics. But then there are other topics, more applied in a sense, which are really very motivating for this program and for data science in general. For example, neuroscience, computational biology, human-computer interaction, cognitive sciences. So these are all areas of research that are rich of activity here in Padua. So this is why we thought that Padua was really the right place to build up this program and to offer this program. And so, what about this program? So what are the details, the technical details of this program? First of all, a few words about admission. So I'm only saying very few words about that. I mean, if you want to have more information, please just visit the website of the master. So we have, this is a program with the so-called numero programmato, so with a fixed maximum number of students. We have at most, we're going to have at most 10 non-EU students and 40 EU students. So the call for admission for non-EU students is now closed. Okay, so we had, just for general information, 37 applications for 10 places. The call for the EU students is open and will be open until September 1st, so do not forget this deadline. And so one of the key points of this program is that we would like to have, and so we welcome students coming from different undergraduate backgrounds. So I just mentioned what are, the background that we thought would be typical, but they are not necessarily exhaustive. So statistics, computer science, engineering, mathematical physics, biology, economics. If you look at the website of the program, you will see exactly what are the minimal requirements that are needed for entering the program. But this program is really designed to be inclusive, to be attract students from different backgrounds. The selection will be done on the basis of the student curriculum. And as I said, more details are on the web page. So how is the program designed? So it's a 2-year program. So it is designed, the courses are distributed into 3 semesters. So we are going to have the core courses, which are, say, the technical core of the program, which concern the computer science part. So there are 24 credits in computer science and engineering. Then there are 12 credits associated with mathematics, particular stochastics and optimization. And then there is the part related to statistics. So this is the core part. So what certainly, I mean, these courses are to be followed by all students. And I mean, after that, so we have decided really that this had to be a multidisciplinary course. So we wanted to have a certain number, namely these 3 courses, which in a sense are courses about application of data science in a specific context. And we wanted that all students have a minimal exposition to these applications. So these 3 courses are also, I mean, mandatory for all students. So one course is about behavioral science and social sciences. One is about the business, economic and finance, and one is about biological data. So these are really, I mean, hot applications of data sciences. And then there is a number, not so small number of credits which are elective. So students can choose their courses. And actually, I mean, this gives, I think, a good room to really design a program which can be, for example, more oriented to theory, to the technical part, or more oriented to an application. And we will offer a number of courses. Courses can be these elective courses that can be chosen by the students. And you see here are listed in a random order, just, I mean, deciding that on purpose. But you see there are courses, for example, you see this related to mathematics, mathematical models and numerical methods for big data, or methods and models for combinatorial optimization. These are more mathematical oriented. But then there are, I mean, you see, for example, this course Law and Data. This will be taught by a member of the Department of Law of Aula, because of course, you know, data has a lot of legal aspects that are relevant, for example, concerning security or privacy. Then we have courses related to the biological application, you see, bioinformatics, or introduction to all disciplines. Then we have courses, I mean, more engineering oriented, like game theory or network sciences. We have courses more oriented to application in cognitive sciences, like cognitive service or human data analytics. So we have a package, and I also want to say that only a minority of these courses are, you know, are courses that are already existing in some other master degree. And so we just take these courses. Most of them are being specifically designed for this program, so these are really new courses. And so I mean, just to show that there has been a certain effort, I mean, in the construction of this program. I showed, I mean, how the first 3 semesters are organized. The last semester is devoted to stage, to an internship, and the thesis that will be strictly related to the internship. And the internship could be, I mean, you can have an internship either in a private firm, in a public institution. Here are some examples, for example, ISTAT, Azienda Ospedaliera, or in research center. For example, our partner FPK has many research centers, but also in university labs, CNL labs. So we have a pool of contacts, I mean, of both private institution, public institution, research center that have already told us that our students will be welcome for internship. So just to make sure, I mean, the internship is mandatory for all students. Each student will need to have an internship fourth semester of the program. Another aspect of the program is that also thanks to the partnership with FDK, we're going to have a laboratory which will be dedicated to data science. This data science lab will be built and will be really dedicated to data science, and not only to this master's degree, but also for PhD and also for activities related to data science, but maybe in partnership with external partners like private firms or whatever. So we will also have a laboratory which will be dedicated to data science. Okay, as I said, if you want to have more information of the sort that I have been given in this short talk, you just visit the site, the website of the program, or you can contact me. I am Paolo Dai Pra. I was one of the members of the pool that have built this program, and so you're welcome to write me, to email me for any information you may need. Okay, so this is all I have to say, and I really would like to proceed with the program. So as I said, if you have questions related to this first part of this presentation, I will postpone this question to the end. And so I would like to introduce our first guest. Okay, so our first guest is Emanuele Baldacci. Emanuele is currently the Director of Methodology, Information Technology and Corporate Statistical Service at Eurostat. For years he has been head of the department at ISTAT, the Italian Statistical Office. He has also worked for the International Monetary Fund, for the World Bank, and I think this is not all, but this is okay. He has a PhD in demography from the University of Rome, Florence, and also Padova. He is the author of many scientific publications, and subjects of his research is fiscal sustainability, macroeconomic risk, population aging, and social protection, and official statistics modernization. So, thank you for coming, Emanuele.
Thank you. Thanks, Paolo. It's a great pleasure to be here. In the next 15 minutes, I would like to convey you a few messages in terms of what could be the skills and competences that organizations like the European Commission will be demanding on the market in the next few years. In fact, I'm working for the European Commission, particularly the corner of the European Commission called the Eurostat, which is the equivalent of ISTAT in the case of the Italian friends, so the producer of data, of official statistical data for the European Union. The Commission has already launched very recently a first call for data scientists, people that have the characteristics that I will elaborate in a minute on. And we are recruiting about 20 people just now, as we speak, that will be posted in the different Commission services in different parts of the European Commission to do work. Do work on what? Try to ask yourself how do you design a program that helps lift people out of poverty without providing negative incentives for people to work. Or ask yourself questions of where are the gaps in the European labor market in terms of skills, mismatch between the demand of skills and the supply of skills, what companies and organizations want, let's say, from the market and what the market can provide. Or questions like what are the ultimate impact of the money that we're spending in Europe on, let's say, research, for example. Europe has a big pot of money that is channeled to research funds to support innovation in several fields. Is this going to be effective? All these questions require an answer, and the Commission, who is the ultimate responsible for providing services and delivering public policies in the areas that I was mentioning, has to use increasingly data to answer these questions. And the data that traditionally were collected and are being collected from sources that are from administrative records or from traditional statistical sources, typically somebody filling a questionnaire, both online or a physical questionnaire, are increasingly becoming outdated, if you want, to answer the type of questions that we want to answer. In terms of timeliness, in terms of amount of granularity, the type of details of the information that we want, and because they may be having gaps, not answering all the questions we want. Fortunately, we live in a very fortunate era, which somebody has labeled the data revolution. If you want to take a more evolutionary stance, you can call it data evolution. These data are increasingly being produced without even us noticing. Because they are produced through smartphones, they are produced through technical devices, they are produced just as we go, because we leave tracks behind that can be used to provide answers to these questions. And organizations like the European Commission, but more generally organizations, government organizations which are responsible for public policies, will increasingly rely on this type of data and the brains that are needed to associate this data and give sense, make sense out of the data, extract signals that would give answers to questions to do their job. So that's why I'm here today, because we in the European Commission are very much interested in recruiting people who can do this, who can identify the data sources that are needed to answer questions, put them together, process them through sound methodological approaches, and then be able to communicate results to policymakers, to members of parliament, to stakeholders, citizens at large, and help make sense out of the data. Now, where are we? Are we ready? This is just a little statistical table, chart, in fact, that shows that, for example, in Italy, we tend to be using digital technologies more to have fun than to, let's say, do business. More generally, if you had to plot other dimensions, also for Europe versus other parts of the world, Asia and the US, the same would hold, that we're not using data to their full potential to do, let's say, high value added things. Not that the game industry is not an important component of our future, but there are many more things that we could do using data and digital services more effectively. For example, think about government services. We're still, in many parts of Europe, filling things on paper or doing things twice. The administrations are collecting from us the same information in multiple ways. This is a waste of time, eventually it's a waste of patience, and also a waste of money. So in the future, we'll have to have all these bars and several more raising to the top with more and more digital services, data-enabled and technology-enabled, which hopefully will make life easier and better for everyone. And again, just to give you a scenario, I was mentioning that data are produced as we go in several different ways. What experts tell us is that we live already in a world that in the next decade will look like that. The Internet of Things, or Web 3.0, it's a place where not only small portable devices will produce data that can be used for analytical purposes, but everything from our microwave to refrigerators, the cars we're driving, the airplanes, everything will generate tons and tons of data. But that in itself is not necessarily meaning that we will have more information. We need these devices and this data that are produced to be interoperable and interconnected. And we need to have sound infrastructure that would allow the seamless transfer of this information from one end to the other, so that the information can be assembled, can be processed, integrated, and then again, signals can be extracted. This, however, for a statistician like myself, changes completely the world. I will not bother people and companies anymore with questionnaires. I will not go necessarily to read into the administrative records of different governments to extract the information, because I will have tons of potential information to provide figures, provide analytics to my bosses, to the people who are sitting in Parliament, people who are sitting in the government of the European Union and are asking the questions that I was mentioning at the beginning. How can I solve this problem? How can I know in advance, for example, through a sensing system, that many people are coming to the southern borders of Italy, migrants coming from Northern Africa, for example? Is there a system that I can use to track these things in advance so that I can get better prepared to provide assistance to people who are moving overseas? Or, similarly, knowing that there are gaps in the labor market, how can I address these gaps in advance so that companies requesting certain competences are not, let's say, unable to hire them? Now, this means that any organization, and definitely my organization, the European Commission, will need to invest heavily in putting data which are coming from different sources together. And I just mentioned 4 different sources, but you can add as many as you want. You can have videos streaming, you can have voice, satellite images. But these are typical, let's say, traditional sources, which can be enhanced by the Internet of Things modalities of producing this data, and that need to be put together. Now, all current organizations do not have data lakes. They still have systems that are very much highly structured system of storing the data, and then they process the data, they query the data, using the ex-ante structure in the data. That's not going to work in the future, because we will know less and less what the structure of the data will be, and we will treat several different sources of data in a non-structured way. Now, why am I mentioning this? Because I will come back to this, but this will be one of the core competences for the data scientists that will have to work in places like the Commission. Tell me what type of data do I need? Tell me how do I put together data which are coming from satellites with data which are coming from administrative records? How can I combine them, even if these data were not designed from the very beginning to be combined? They may look very differently. How can I combine a video stream, which tells me that people are very angry at the European Commission because they're not doing anything in a certain policy area, with information that is coming from social media and information that is coming from answers to questions? So again, data integration requires an environment where I can put all this data, and a platform where I can put all this data, and despite the fact that this data look differently, I can treat them as if they were the same, or at least I am enabled to do that. Then for my organization, I would need to look into 5 capabilities, which will allow my organization to reap the benefits of new technologies. And again, you'll see that these capabilities will come back also in the forms of skills and competences. But any organization, be it in the private sector, public sector, including the Commission, will need to look into how to enhance the skills of their people, to enable them to do the type of things I was mentioning, methods, so what is the theory and the applied methodology that are used, review the processes and tasks, because probably we can do things differently if we have different information streams. For example, the typical life cycle of a policy is that we first collect the needs. So we understand that we need to know more about skill gaps. Then we start measuring what does it take to address the issue. And then we measure, once the policy is in place, what the implication of this approach has been, whether we've been successful or not. Well, if you have more information and you have, let's say, real-time information, then you can compress the time span, move immediately from a snapshot to, let's say, a movie that tells you information as you go. So you can basically have constant information that would allow you to design, implement, monitor, and revise policies on a continuous basis. This would shorten, for example, the time that is needed to design, implement, and redesign a policy. If something goes wrong, it's better to know it early on, fail fast, and then move back to the blackboard, redesign the policy, and try to improve it. Again, more data, faster data, data that are coming from different sources would allow us to do that without waiting for the results of an assessment based on traditional data sources. And then we need to have capabilities in the application technology. Most organizations will purchase this. They will not develop them in a house, but you would need anywhere, even in places like the Commission, which is not necessarily, let's say, Google, people who are responsible for information systems, communication networks, information repositories, or know about them so that they can purchase them from the market as a service. As the IT market will develop increasingly providing these capabilities as a service. And then you need standards, because as data are coming from different devices, information is coming from different sources, you need to have interoperability. Interoperability means common languages, ontologies that would allow you to put together things that otherwise are not possible to mesh up. So what are the skills that I would like to have in the people that I will recruit over the next couple of years? Well, it's a combination of the skills that you see on the slide. Definitely math and statistics are very much important, but by themselves they are not sufficient. I need substantive expertise, meaning that I will need to know, for example, if I have to study a problem in the labor market, I would need to have someone who knows about the labor market. And then what I call the hacking skills, which is coding plus. And it's not purely, let's say, ability to have basic knowledge of computer science, but a problem-solving oriented ability to dig into the data, discover structures in the data, profiles in the data, information in the data, which are not evident. And the best possible way to answer a question in the future from your boss is to anticipate the question. Don't wait until your boss has a question for you. Dig into your data, come back with a solution that could be a problem-solving solution, and you say, my dear boss, you haven't thought about this, but if you were to put together these two data sets which are sitting in two different departments of your organization, maybe you can learn more. Maybe you can exploit better your data which are sitting there idle, they're not producing any information, and basically for zero cost, or zero marginal cost, because the data are already there. But what is important here is that, in my view, and not just in my view, because this is something that I took from someone, data science is really at the intersection of these skills. So having these different skills alone would not help you or help us as a recruiter of data scientists. It's really at the intersection of these skills that you need to have competencies. And moving to competencies, I like to call this datacy competencies. It's not a very nice word, but datacy is the combination of data and literacy. So data literacy competencies, if you want. And for me, there are four which are really very important, and I look forward to having these competencies in the people I'm going to hire in the future. First is data sourcing. As data will be of different forms and different measures, I need increasingly people who understand what kind of data I'm going to use, and be creative about that. Again, in the marketing industry, they're increasingly using videos, for example, to develop systems of customer satisfaction. You're not anymore or any longer just requesting customers to provide feedbacks. Maybe from the facial expression of people, you can get more information than from someone pushing a button with a smile or an angry face. So I need someone who is able to go and mine for the information and dig the information. And in many cases, particularly in the private sector, but also in many organizations, the information is sitting somewhere in your office and it's not used. And this is where you would really need to dig and be able to source the data for answering problems. Then you need to be able to think about data process management, which in the end means integrating the data in a meaningful way, using some strong stable model, I would say, that are replicable over time, that look into association, causation, correlation, and that can give you some answer, including in terms of prediction. People will be increasingly asking questions about the future, not about the past. I'm a statistician. I'm typically used to taking pictures of the past, telling you what GDP was or what poverty was a year ago. Increasingly, the question is, I want to know now what is poverty now and what's poverty going to be tomorrow. So this is going to be the answer, the question that we will be asked. Particularly in the policy domain, where everything is now. Technology manager, you need to be on top technical stuff. Otherwise, you do not understand the rest. So you need to have the type of skills that Paolo was mentioning in the introduction. And then, final point, very much important, relationship and engagement. You don't build a data science teams of solo players. This is really a team game. So you need people who are able to engage in relationships, not only with their colleagues, with their customers, the stakeholders, their bosses, and also the data providers in some cases, because the data may be in the corner of your organizations, but they may be sitting in the corners of someone else's organization. And if you are able to create relationships and alliance with these people, you can get information which are valuable for your company and your organization. And you need engagement in the end, because this is a funny job, and so you need to be motivated, energized, and transfer this energy to the rest of your team. So this is how the modern data scientists look like, and we didn't coordinate, but I think that most of the type of skills that are listed on the chart are very much included in the offer, in the program that is provided in these data science courses. There's math and statistics, programming and databases, domain-specific and soft skills, and communication and visualization. Being able to extract complexity out of a problem and communicate clearly to those who have to receive the message. What is the story? That's key. That's 100%. You can do everything best and then stop at the communication part. I could not emphasize this more. This is 100% important. I've seen in many boards of the organization where I worked, incredibly, terrifically well done jobs being trashed because you communicate too technically, you communicate without a clear focus in terms of what is the business impact of what you're telling me, or you're lost in the details. So again, communication, that's very important, and it doesn't come naturally. I mean, we need to learn constantly how to evolve our communication skills. Now, the good news is that we're going to make a lot of money out of it, and this is just to show you that not only the data scientist jobs are demanded increasingly, not only the data scientist jobs are, let's say, fashionable and the current hype, so that sometimes they ask more basic tasks, but still, rebranded as data scientists, they are like very attractive not only to people who are applying for jobs, but also within the organization. Everybody wants to move to a data scientist position, a data scientist team. In our organization, I created a data scientist team, and I had people knocking on the door or lining up in front of my door for weeks because everybody wanted to be there. They understood that this was the future, and so this is important. But what this chart shows is also that you have an upscale. So at least in the private sector, but to a certain extent more limited also in the public sector, you move up fast. Because the data scientist today is seen as a problem solver. If you do the job right, then you're really contributing to the bottom line of your company. And that's my last slide, and it's very much based on this final remark. It's from the boss of Monster Worldwide, which is an international company responsible for job placement and job management. And well, basically you can read the lines, but the important thing is at the end. So what we do is for business. Business can be policy making, can be making profits, can be humanitarian assistance, whatever the core business of your organization, you put your data and your data crunching skills at the service of business. So there's a purpose, and this is very important for the communication part I was mentioning at the beginning. You need to show that there is a bottom line what we're doing. Just pure research, it's good, but it's not good enough. Research for a purpose that answers questions, that's 100% top mark, and the boss is happy, your organization is happy, and you're doing your job as a data scientist. So I hope I convinced this is a sexy job, and it's fun enough also to invest in this type of opportunities. Thanks.
Thank you very much, Emanuele. I forgot to mention at the beginning that this little event is we everything is given in English for two reasons. The first reason is that the English will be the language of this master degree, all courses will be taught in English. And the second reason is that the video of this event will be published on our website, and hopefully is available also at the international level. If you have questions, then you feel more comfortable in asking questions in Italian, you are welcome. So if you have any immediate questions to our guests, okay, so if not, we proceed to the next speaker. Okay, so our next guest, Giuseppe Sartori. Giuseppe is a full professor of psychobiology at the Department of General Psychology, and is also the director of the master program in psychopathology and forensic neuropsychology, and also director of the School of Specialization in Neuropsychology. He has written a number of influential papers, and his research interests include neuropsychology and forensic psychopathology. So I thank you very much for being here.
I'm really working in the field of research in behavior of web users. So how web users move around in a social network, or this is one field I'm working. I'm working also on online lie detection. So when you fill up a form on the web and you are trying to fake some information, how can you detect whether information is faked or not? This is another issue I'm working on. And I'm working as a cognitive neuroscientist. I'm working on machine learning models of mind reading using data collected from brain imaging. So the starting point is the activity of the brain, and the use of machine learning models is done in order to predict, classify the mental state that corresponds to a certain brain activation. So this is an example of interaction between psychology and data science. So psychology is the field where we study behavior, where we study cognition, and where we study mind-brain interaction. So how the mind arises from the brain activity. So this is basically psychology, and there is, I think, an important field of interaction with data science. I just give you some examples of issues we can that will be addressed during the course. The issue of detecting fake reviews. You will probably know that one issue in social networks or sites like Yelp or TripAdvisor is fake news, so fake summaries, fake reports. People who go into the site and describe that the restaurant was extremely good or extremely bad, but in fact they didn't go to the restaurant, or the evaluation does not correspond to what they wrote. So this is a very important issue for this moment, and this is related to how people deceive information, how they intentionally modify their verbal report, in this case during writing a summary. Another important issue we are working on is fake identities. You probably know that the terrorists in Berlin, Brussels, were were reporting fake identity information. For example, the Berlin bomber, Brussels bomber, sorry, kamikaze was using an Inter Milan football club player as a fake identity. So an important issue is how can we check whether the identity of a claimed identity, sorry, of the same migrant is a true identity or a made-up identity. We are currently working and have solved the problem using movement coming from mouse analysis, how in responding the subject is moving the mouse, keyboard dynamics, how is responding using the keyboard, and what is interesting is that we can using machine learning technique, we can come out with high accuracy in deciding whether the guy who was responding using the mouse movement was a liar or a truth teller, and also from the keyboard dynamics. Another interesting, for example, this is the trajectory of a truth teller who is responding and the liar who is responding. All this information is analyzed using machine learning and achieving high accuracy in auto-sample classification. This is an example of a real trajectory of a truth teller that is quite straight to the target response, while the response from a liar is quite erratic. So this is an example of how we can apply behavioral science to issues related to human-web interaction. Keyboard dynamics is another issue, but I want now to show you another argument that will be addressed in the course, which is basically a clinical issue of using high-dimensional classification of brain images. For example, how can we blindly classify whether a brain is one of a depressed subject or for a healthy subject? This is a big issue in clinical science because the neuroradiologist cannot distinguish just by visual inspection of the brain scan whether the brain is coming from a healthy control or from a depressed subject. So in this case, machine learning systems are carrying out the classification with high accuracy. In the field of clinical neuroscience and cognitive neuroscience, we have now available a huge number of databases where there are whole database of schizophrenic patient, brain coming from schizophrenic patient, depressed patient, and all other psychiatric disorders are available, and the researcher can use this database to develop models for classification. Another very interesting issue is the following. It's called brain reading or also mind reading. It's basically using the response of the brain taken from a functional magnetic resonance in order to predict what is the corresponding mental state. For example, there was some time ago a competition where researchers were given brain scans of people looking at the film, a Western, the good, the bad, and the ugly, and they were supposed to detect the very moment in which the brain was looking at a pistol. And in this international competition, the winners achieve the high score in detecting whether the brain was looking at visual. Another interesting issue is, for example, predicting behavioral features of a user of social networks. It has recently been shown that you can predict the personality of a user of social network on the basis of which news he is looking at, on the basis of the distribution of likes in the social network, and the classification, the machine learning classification of the personality of the user is higher than the prediction of the personality of the companion, of the spouse of the subject. In other terms, from the social network we can achieve a personality description which is more accurate than the description that we can take from, say, husband or wife. This is very important because we can also predict the criminal disposition of the subject, because the criminal disposition can be predicted from some of the sub-features of personality, and we think that in the future we could be able to screen high number of social network users for their propensity to crime. These are just a short survey of how there is maybe an interaction between psychology and data science, and this content will be addressed in the course on cognitive, behavioral and social data science. Thank you.
Okay, so the next speaker is Luciano Serafini. Luciano is head of the data and knowledge management at the Fondazione Bruno Kessler at PK. He has rich activity also in terms of organization and services for our university system, more noticeably as being a member of the Gruppo di Esperti di Valutazione, which is a restricted group of people that have evaluated at the national level the research within the university. And he has written a number of papers, very influential, and his research interests include artificial intelligence, logic for knowledge representation, and multi-agent systems, semantic web.
Okay, so I'm going to, it's a very, for me it's an honor to introduce what we do in Fondazione Bruno Kessler, but it is also a challenge because we have so many research and activities that for sure I will not be able to describe them in a very detailed and with all competences, but I will do my best. So first, well, a very short story of Fondazione Bruno Kessler and why it is called like this. It is named after Bruno Kessler, who is the starter of this Fondazione. Here you have a long history back to 50 years. And it started with, it was the first basically university in Trento, and then it got privatized and so on. So I'm not going to detail. But at the end, one important part, so it started with very humanistic direction, and but in the last years it get very much involved in information technology, in artificial intelligence, robotics, and these kind of activities. And I think that's why I'm also here, right? because of these competencies. So, okay, as I said, Fondazione Bruno Kessler, as now I concentrated on the more on the technological part of Fondazione Bruno Kessler, and we basically has two core. Sorry, I don't understand why it was so fast. Okay, we have two core parts. One is the information technology department, who is basically devoted to develop all the area in information technology, like software engineering, natural language processing, vision, artificial intelligence, all these kind of activities. And one department that is more devoted on material science and microchips producing. We have our own factory of it's a clean room for producing small sensor, small circuits that we can use in our experiments. On the other hand, the human research part is composed of Istituto di Scienze Religiose, Istituto Storico Italo-Germanico, and an Institute for Analysis of impact of politics that is interested in measuring how much the political decisions impact the life of the people, basically. So to try to measure with some concrete and effective measures. So again, concentrating on the, and overall, we are about 400 researchers, and among them we have we have around 100 PhD students. So not only research, but also high-level formation with PhD students. We are also interested in organizing stages and formation for, and we collaborate with many universities for the formation of students. Okay, they can visit us, do stage, join for projects, and so on. So they can have an early start of the research and development career. So, what is the main mission? The main mission of FBK, we have these 5 points. First of all, we believe that innovation and other things is based on high-level international research. So, it's only by doing very good and worldwide recognized research that we can manage to achieve also good result in innovation. Second, we want to attract a good student. I mean, top student and top researchers. The environment is very international, and our recruitment methodology is based on open calls. We are particularly interested in internationalization, so to keep a relationship and partnership with many different institutes around the world. I mention only a few, like the Massachusetts Institute of Technology in the United States, various, the Imperial College in London, and other researcher and other research institute and university around the world, and among them also the institute and the university in Italy, and University of Padua is one of these. Well, we want to have also social impact and technological innovation. So we don't want, we think that just doing research is not enough. Research should have an impact on the society, on the life quality of the people. And this is also the, and should have also an impact on the economical organization of the society. So going to the first point, so what are the research? How is research and innovation organized in the Information Technology Department? It's basically organized in 3 research lines, as you see the 3 on the top. One is called cognitive computing, that has something to do with everything that has to do with the interpretation of the human information, human interaction, so text, images, audio and video, audio interpretation, machine translation, human-computer interaction. So all these kind of things are organized in a unique line. Okay. So these, to give you an idea, this is about 60 people doing research in different aspects. Then the second line is complex data analytics. This is something quite close to what has been discussed today. So building up mathematical models and that are capable to analyze data and provide explanations for natural phenomena. An example of activity that is done by this group is definitely the analysis of the fMRI of the brain in collaboration with the CIMEC, which is an institute in Trento for analysis of brain images and neuroscience, and also analysis models for analysis of the propagation, for example, of propagation of viruses around the world and things like this. The third point, the third research line has something to do with more on software engineering. So many of the model, I think the majority of the model application is based on software. And if this software is not correct, then we really have a big problem. That research line is basically devoted on developing technologies and techniques for analyzing software, developing correct software, checking if software is correct, and if it follows the specification given by the users. Then we have what we call the 3 high-impact initiatives that somehow take the research done by the 3 research lines and try to put them into the reality. And this is done, of course, not by their own, but in collaboration with the other. And one is more, has something to do with more what is called smart communities. So all the applications that involve citizens and the improvement of the quality of services by public and private administration and so on with the citizens. The other one has to do with health and well-being. You can imagine how many applications you can have in health. And the other one has something to do with the analysis of the new media, of the new social network, of the new data that you can get from the internet. Well, we have an important thing is our international PhD program. So as a research center, we are not allowed, we are not entitled to give a PhD. So we give a PhD through our collaboration university. So we collaborate with around 10 or 12 universities around the world, among which University of Padova, and we have built up like a group of around 100 PhD students. And here you see we celebrate our the PhD day. For every year there is a PhD day. And well, I would like to, instead of me presenting this, I would like to give you a short video that our director is presenting it.
The goal of this program is to train highly specialized doctoral researchers, and we achieve this by offering them a unique and stimulating research environment.
When I arrived here, I didn't have a background in computer science, but I had the possibility to grow, to be in contact with researchers with a more technical background, and this is definitely a plus of FBK, where I found the opportunity to do really what I like to do most.
This environment includes a network of international collaborations with top-ranked universities, among which the MIT, the University College London, and the Imperial College. These are actually the universities that deliver the doctoral degree.
So one of the exciting things is that students will be able to go back and forth between MIT and FBK and work on these researches and be able to have access to more sort of facilities than they would at either one alone. And I think that's the trick that will give them lots more benefit than just being at one institution or the other.
We offer our students well-equipped laboratories where our research is carried out under the supervision of top-ranked researchers.
The facility and equipment that you can find here are unique in Italy. And some research are carried out together with companies and industries.
This is very important when you finish the PhD. So the kind of exit you can have from the PhD is maybe more diverse than the kind of things you can have in a traditional university. So you can go further and doing the academic life, or otherwise you can decide to go in one of the research center of the big company. So we have a lot of students that did the PhD in FBK that now are in IBM, for example.
During their PhD, you have the opportunity to attend conferences, summer schools, and so to get in contact with other institutions very early in your career.
Trento is offering a very good environment for research. The fact that Trento is part of the EIT, the European Institute of Technology, is the leading Italian node of the European Institute of Technology, and FBK is strongly involved in the project that are driven by EIT.
We promote quality. We have an excellence program that rewards our best students and help them target the highest quality standards.
These are all the perspectives that FBK can offer to students to build their own bright career in the future.
So in order to do good research in data science, you need computational power, you need computational memories. So in FBK we build up, we have a core, it's called Core KOL, it's a cluster that has more than 100 GPUs integrated in one single cluster systems and quite a big number of computational and storage power. And this core is made available to all the research group in FBK, and of course also to the researchers that are doing research in collaboration with us. The typical, here is a list of our activities that research that we carry on using these core systems. They have to do, as I said before, software engineering, functional genomics, global scale simulation of pandemics, automatic speech transcriptions, information extraction from text, images, and other medias, content acquisition and integration, and all the other things. And we also recently opened some new activity about quantum computing, especially this in collaboration with the microsystem units. As I say, another point is internationalization. As we are in Trento, as in FBK, have been one of the most important promoter of Trento to be one node of European Institute of Technology, EIT. So in 2 words, because it's very difficult to define it, but European Institute of Technology is a distributed institute. Is distributed, as you see, along the different capitals in Europe. Well, Trento is not a capital, but it's there anyway. The main goal of EIT Digital is to promote interdisciplinary research and innovation in Europe, of course, in information technology. They have different programs. They found industry-level PhD. They found also projects and joint projects that allows people to travel around the different nodes. Okay, so what about impact? Impact with the companies. We have a strong connection with local industries, but also with the national and international industries. Our mission is also, we are founded by the local government, but we also have to raise money from other projects, from the European Commission, of course, but also we need to have a collaboration with industries that fund our research. Again, on this topic, I ask somebody else to help me on this, and I would like to show a short video about our collaboration.
La Fondazione Bruno Kessler si apre, diventa un luogo in cui l'open innovation non è solo scritta, ma è fatta. Credo che rappresenti una nuova grande opportunità per il territorio e per la sua crescita.
Noi facciamo ricerca, siamo famosi a livello internazionale nell'ambiente scientifico, ma l'impatto non deve limitarsi a quello dell'ambiente scientifico, deve anche andare sul mercato, sulla società. Per questo una caratteristica nostra fondamentale è proprio stabilire queste relazioni con le aziende, con le istituzioni pubbliche, in modo da lavorare assieme.
E lo faremo attraverso 3 livelli: degli spazi di coworking, dove le persone potranno lavorare insieme. Lo faremo con dei laboratori di cooperazione, in cui ricercatori e persone di azienda svilupperanno progetti di giorno in giorno e ospiteremo le aziende.
Credo che si possa instaurare un ciclo virtuoso fra chi spinge sulle tecnologie più avanzate, sui problemi di ricerca, e chi invece ha il problema di fare dei servizi e dei prodotti che devono andare sul mercato. Noi capiamo meglio le esigenze del mercato e l'azienda può arrivare più velocemente a introdurre le innovazioni nel loro ciclo di prodotto.
L'integrazione di competenze e di domini molto diversi ci ha portato a guardare fuori dal nostro, per così dire, perimetro aziendale, e in maniera quasi naturale abbiamo identificato in FBK un partner che poteva portare grande valore proprio in termini di nuove competenze, nuovi domini, nuova conoscenza.
La nostra collaborazione con FBK è una collaborazione che nasce da lontano, abbiamo fatto molti progetti europei insieme. Oggi ci sta concentrando sul tema delle Digital Cities, dove in particolare stiamo provando a mettere in piedi un nuovo modello di integrazione dei dati di tutti i fornitori di servizi a livello del territorio e a avere una sperimentazione che impatti sul territorio trentino.
Kind of life that you do here in this research center is not only the purely academic life. You spend also part of your life working with company, doing research project with them, and this is very important when you finish the PhD. So the kind of exit you can have from the PhD is maybe more diverse than the kind of things you can have in a traditional university.
Credo che questo sia la cosa migliore che si possa fare, perché diamo l'opportunità ai ragazzi di avere esperienze professionali di grande livello e poi io mi auguro che molti di loro possano trovare esperienze professionali anche in altre aziende, in altri enti di ricerca, oltre naturalmente per alcuni la possibilità di restare con noi.
So in the last part I just summarize in a few words some, really 3 projects, but there are so many and don't think that this is the only one, okay? Well, the first project where I am personally attached and really a fan of this is what is called Understanding Multimedia. As I said, in FPK we have a lot of groups. Every group is specialized in image processing, video processing, audio processing, text processing, knowledge representation. But humans are capable to look at the video, listen to the speaker, and read the subtitles, and put everything together with its own background knowledge. So, in this project, we would like to build up a system that is capable to do all these things all together. So, to analyze a video and at the same time to listen to what it says by the speaker, for example, in the video, understand it and connect it to the video. So, if a speaker says a name of a person, the system should be able to identify the person in the video. Okay, and to recognize the action that the person is doing, or what is happening in the video. Furthermore, you can, in the internet, about video, you can find a lot of additional information. Suppose that you are looking to a movie, you can go to the Wikipedia, you can go to many resource video internet and get a lot of additional information, and you want to put them all together so that you have a kind of integrated understanding of what is going on. This is a very challenging project because it involves competencies in vision, natural language processing, speech recognition, knowledge representation, and all these things. And you have to put them all together in a unique framework. Second project is done in collaboration with Massachusetts Institute of Technology, and this has to do with what is called social physics. This type of activities has been described also by our previous speakers. So now you have users with mobile devices and with all the internet applications. They provide really a lot of data from which you can extract the behavior of the crowd, of the community, how the system evolves, and you could basically apply a lot of methodology that has been developed in physics to analyze these type of systems. So, okay, we have projects in this, and we use data, for example, that are provided by Telecom Italia and by other telecom customers. A third project has to do more on the health. So this is an application that somehow help users to conduct a healthy lifestyle. So the system collects information from your activity in your mobile phone, and also the food that you take, the activity that you do, and especially is devoted to the people that present some type of diseases that described there, and suggest to have, say, positive behaviors, so that you can imagine that your behavior will improve your health, will improve your health. But the side effect of this is that you collect so many data about people that you can analyze them and get really a lot of information of the behavior of the people. We are really running these on, of course, one of the important issues here is privacy. You have a lot of private information and that user don't want to give away, okay? But if you solve this type of problem, and this needs to be solved actually, then you really get access to a lot of information. And well, this is the other project so for the time being, let me finish by saying that FBK is open. It's open to collaboration. It's open to everybody that comes and wants to visit, to have a joint thesis, join stages, join PhD, and to open people and to make them to participate in this type of projects, to be like a bridge between academics and companies. We really have a lot of people that get the thesis with us and then they are now working in a company, or that they get the thesis, they get the PhD, and now they are in academia. So it's really the network after like 30 years of information technology is really a big network. So you're really welcome. And data science is very interesting and we want to be there. We want to play our game. Thank you.
Thank you very much, Luciano. Is there any immediate question for Luciano? So, I just want to say that I'm really happy for the insight that our guest gave us about data science, about how diverse, deep, but also exciting the applications of data science can be, and how many opportunities are offered to those that have skill and knowledge on this field. So I propose just a last applause to our speakers. Okay, so this is an open day, so now it's really the time in which you can freely ask questions to any of us. So we are going to stay here around. There are other members of the committee that have organized this program, so you can also ask questions related to specific context of this program. So we are staying, you're welcome to stay, and if you want to take with you a little booklet about containing some information on this program. And I just want to thank everyone for being here and staying and with my best wishes for the future. And I hope to see many of you here back in October. Thank you very much.